So, welcome to our presentation on embedding insight through prediction-driven logistics. I'm Andy McMahon, Analytics Team Lead at Aggreko, and today I'll be presenting with my colleague Helena Orihuela, who's a Senior Data Scientist also in the Analytics team. I'm going to start off today with a brief introduction to Aggreko and what we do. I'll then explain how we work in extended collaborative teams to ensure that our data science and machine learning projects deliver value and answer the right questions across our business. I'll introduce you to the idea of predictive alarm management at Aggreko, and then after that I'll hand over to Helena, who will take you through a particular use case of applying machine learning to fuel tank level forecasting and how that benefits our operations. Helena will finish with a quick demo, and then we'll summarize and take any questions. So first of all, who are Aggreko? Greco is a world-leading provider of mobile modular power, temperature control, and energy services. We work at the forefront of a rapidly changing energy market and are focused on solving our customers' challenges to provide cost-effective, flexible, and now greener solutions across the globe. We harness innovation that helps us maintain a global reach and supply portable equipment for a wide range of use cases. So that could be anything from unique commercial industrial projects through to utility scale power provision, or even responding to humanitarian emergencies. We bring expertise and equipment to any location globally, from the world's busiest cities to its most remote places. And our overall mission, which is up on the screen here, you can see has a particular focus on making a positive impact through those solutions, which makes it a really exciting place to do data science. I've got some numbers here about Aggreko, just to put in context the scale of that impact I was describing. So in our power fleet, we have over 10 gigawatts of distributed power available, and that consists of a variety of generators and associated equipment. And these look like the four boxes you can see in the top left hand of the slide here. And they come in a variety of flavors, from diesel, gas, next generation biofuels, through to renewable hybrid systems with industrial scale battery storage. In 2019, we took over £1.6 billion in revenue across 265 locations in 100 countries, and we currently employ around 7,000 people. So we really are global in that reach and impact. But given the nature of this summit, you'll obviously be asking the question, how do you work with your data? So like any business at Aggreko, we're determined to ensure that our data science and machine learning solutions do not become siloed and make sure that they drive concrete business value. So to make sure this happens, we like to work in what we call an extended data team, where we incorporate all of the relevant people with the relevant knowledge from across multiple functional teams to work on any single given project. So for example, in that extended data team, we'll have members of advanced analytics, so the team that Helena and I work at, where we're dedicated to understanding our data at a really deep level and providing a real focus on analysis that provides algorithms, machine learning, and statistical analysis to support decisions. We'll work alongside our business intelligence colleagues who provide real-time operational reporting on business KPIs so that we get the right data to the right people at the right time. We are both supported by a team from data engineering, who are full-time engineers tasked with the ingestion, transformation, and curation of data from across multiple enterprise systems into our enterprise data lake. And then finally, but perhaps most importantly, we make sure we're always working with internal partners from across the business. So this could be experts in technical matters from the US or our operations experts in Dubai. It doesn't matter. They'll be incorporated into the team, provide direction and ownership of the solution so that we know that we are answering the right questions that will drive that business value and ensure uptake of the final solution that we produce. And as I said, the point of all this is to drive value for the business. So what have we actually achieved with this approach? So if we focus on just the past year and the contribution of advanced analytics alone to this extended data team, we've processed terabytes of data using our data lake and associated technologies like Databricks. We've deployed to production more than 10 machine learning algorithms, which are driving insight on a daily basis. And we've generated millions of dollars of insight for the business. So this is the proof that this sort of approach has worked for us. Now, once you have the team, you're going to want to try and build something. And when we do that, we try and operate on a few key design principles. And there's one in particular that I think is really relevant to this audience. And that is that when we produce one analysis, we would like it to be flexible and provide answers to multiple different output channels. So if I take this particular example of generator projects, we'll get data from those assets streamed via IoT solutions, so onboard telemetry units on the generators, through to our data lake, which now uses Delta Lake. That data will then be processed through to our production environment, which is based around Databricks, where we can run statistical analyses and machine learning models. But then finally, and really importantly, we can then surface that result and that insight in multiple different channels. So here I've highlighted 3 particularly important ones, but there are many more across Aggreko. So for example, we could surface the results in a Power BI dashboard and allow users to interact, digest, and really query that data and the insight that we're providing. We could send an Outlook email in order to push alerts or particular insight to specific people on a very dynamic schedule. And finally, but perhaps most importantly for our generators, we'll supply information to our alert management system, or AMS, which I'd like to spend a few minutes discussing now. The alarm management system is an interactive web application that was developed by our application dev team internally at Greco. It provides a single pane of glass where technicians and relevant operations colleagues can view what we call proactive and predictive alarms for our assets. Predictive alarms in this case are those where we have used machine learning algorithms to forecast a future issue, like a part failure, a fuel outage, or a generator completely failing. On the screenshot I've taken here, I've filtered to only those alarms which are predictive, and we can see that they're arranged in an easy to read tabular format. Each alarm provides information on the customer, the services they are paying for, and key information on the asset. We also provide a priority flag to help users effectively triage and prioritize maintenance activities based on predefined criteria. And then finally, the solution provides contextual information such as satellite views, notes on the asset, contact information, and detailed history of any previous work carried out on that generator and on that site. I'm now going to hand over to Helena, who's going to discuss a particular use case where we provide insight to all 3 of these examples I've mentioned, a Power BI dashboard, an Outlook email, and to our alarm management system.
Thanks, Andy. Let's continue with the use case of the field level prediction alarm system for external tanks and their use in logistics. I would like to start by explaining the problem. When clients approach to us to rent fuel tanks, they have the option to diverge their refuel requirements to us. As part of this service, we agree that the tank will be replenished and won't get empty while on hire. By taking this responsibility, we remove from the client the burden of monitoring consumption and arranging deliveries. As Andy mentioned before, we are a global company that works in a lot of different environments. So inside Aggreko, we have a fuel management team that monitors remotely all our tank fleet 24/7. Monitoring fuel tanks is not a problem, but as the numbers increase, this task becomes complex. So fuel outages or high logistics spend can occur. Is there where automated forecasting of the remaining hours of fuel for the complete fleet of tanks help us to plan the logistics and inform the customer of the scheduling times in advance. Moving to the solution, I would like to start with architecture. This architecture integrates a set of technologies in a manner that brings reliability, scalability, and robustness to the insights that we provide to the business. Initially, we find in the bottom layer Delta Lake, where our data lands and is stored. The information here is available in raw format or transformed, depending on our needs. On top of that, we have a layer that contains a set of internal libraries and external libraries. These libraries contain functionality that will help us during the development. Next, we have the data acquisition and modeling pipeline. This layer is composed of multiple Databricks notebooks, which make use of the libraries in the previous layer. These notebooks contain the workflow from the data ingestion to the model deployment. Finally, in the top layer, there are orchestrators. These orchestrators oversee the updating of the models. For example, in this use case, if the model finds tanks that have passed their setup threshold of remaining hours of fuel, the orchestrator will trigger a signal to this messaging interface to distribute the tank information to the different systems. So let's continue with more detail on how the model works. As any other data science pipeline, this alarm system starts with ingestion of historic information. We do this per asset and use up to 2 months of data. The next stage is to do a basic analysis and some quality checks. Sensor data has some caveats, and this is where our collaboration with the subject matter experts had helped us to understand anomalies in the data. For instance, fuel expands with heat, so the fuel level sensor will read this expansion as refueling. This means that environment temperature could add noise to the readings that we receive. So, after cleaning the data, we build a set of bespoke features and fit them into the model. The model is based on a classic multivariate regression algorithm. It is able to predict the remaining hours of the tank, assuming that the tank will be continually used until emptied. When the remaining hours is below a given threshold, it triggers an alarm, as I mentioned it before. The threshold had been established in collaboration with our team of experts. Once the trigger reaches the messaging interface, it will start an Azure Logic app that will broadcast the results. These results are distributed in a slightly different manner for each output system. For instance, in one hand, AMS allows only the alarms where the client is paying for remote monitoring, or Aggreko is responsible for refueling. In the other hand, the Power BI dashboard will contain the prediction for all the tank fleet. Therefore, the field management team will receive this information and use it to schedule deliveries of fuel. In this way, currently, we are minimizing the disruption to the customer and logistics costs to Aggreko. Now, I would like to do a quick demo of the Power BI dashboard for this use case. In the first page, there is some general information about the motivation behind the field prediction dashboard and the project in general. It also contains information of the data that we use and how the model works. Moreover, you can find information of the refreshing rate for the report and the prediction models as they are produced in different systems. And finally, you will find information on how to use the filters and the dashboard in general. Moving to the second page, in this page, we find the fuel tank information table. It contains information about the complete tank fleet currently on hire. It will contain detailed information about the assets, their asset number, who is responsible for refueling that asset, if the customer is paying for remote monitoring, the tank capacity, the latest fuel level reading that we have, the latest predicted remaining hours of fuel, the battery percentage of the fuel level sensor, the agreement number, the off-hire date, and last communication from the IoT to Delta Lake. It also contains information about the customer, service center, region, and location, but I'm not showing that due to its sensitivity. In the right-hand side, we find some different filter criteria that we can use to tailor this dashboard view to our needs, as the asset number, agreement number, region, among others. The colored rows represent assets that have passed the current threshold and the system has fired an alarm for them. If we select an asset and drill through, we will find the fuel plots of this asset. In this page, we are going to find the fuel tank level prediction plot. It is showing us the last 2 months of consumption data for this tank. It also contains the prediction that we have done for the tank if it's used continually until it empties. In the bottom, we have a slicer that allows us to see the plot in more detail. For example, it shows us that this asset is being affected by high ambient temperature, as the fuel level sensor is showing small peaks of consumption and refueling. In the right-hand side, we find extra information about the tank, as the predicted timestamp when the tank is going to run out of fuel, the last 24 hours of consumption after the data has been cleaned, the predicted hours remaining of fuel, and the estimated consumption rate per hour of the asset. And with this page, I would like to finish the demonstration of the Powered BI dashboard and hand back to Andy.
So thanks, Helena. So I'd just like to summarize some of the points we've discussed today. So first of all, hopefully we've shown how at Greco, analytics is really embedded as part of our operational business, and collaboration is at the heart of our strategy and critical to our success, especially for data science and machine learning projects. And that success is critical on us supporting established processes so that we ensure uptake, feedback, and value. We discussed how our global presence, our 24/7 operations, means we have to provide insight in multiple different ways, dynamically as issues arise, and be flexible with the type of outputs we're providing. And our platform and tool choices are designed with that flexibility in mind. And finally, we've taken you through particular examples showing how our machine learning models are driving real value, and we're doing that to the tune of millions of dollars of value annually. The prediction-driven logistics solution that Helena demoed showed how we'll use machine learning and data to drive an improvement in our operational efficiency and our levels of customer service. So with that, I'd like to thank you all for joining and open up for any questions.